Hey there, welcome to another video on math problem solving. This is Bharat Divyan from Zugzwang Academy, and today we have a very simple topic, greatest common divisor. A very simple topic, seemingly so, but can get very complicated when it's applied in certain math Olympiad contexts. So we're trying to understand the nuances of the greatest common divisor or the highest common factor HCF. Okay, so many of you would have seen certain methodology of how this works. For example, the way to go about this, you would have been taught in most math classes, would be to write these two numbers next to each other and then say, okay, is there a common factor? You don't have to find the greatest common factor, but you can find one of the common factors. So I would say, like, for example, directly you could mention that 20 is, because 10 is a factor because both of them are ending in 0 and they're both even after that, 72 and 108. So you can say 20 is a factor. 20 is a factor here. So this is nothing but 36 times 20, and this is nothing but 54 times 20. Right? So again, you can look at this and say that I have 2 as a common factor. So 2 as a common factor, that makes it 18 and 27. And here you could see that 9 is a common factor. And that gives me 2 and 3, and there's nothing common anymore, and therefore to find the HCF all I have to do is multiply these three things together, and you know that 20 times 2 is 40, 40 times 9 is 360, and 360 is the highest common factor. The question though is, why does this method work? What's the reason behind it? That's something probably you've not really delved into it. It's also probably something that most math teachers probably are not going to explain, but the fundamental idea is this. It is to say that if I have to find the GCD of two numbers and they both have a common factor, let's say A, like C, AC is one of the numbers and BC is the other number, then this is the same as having C as a value that's outside as a factor, C times GCD of A, B. So this is what it means. So this is the theorem. This is basically the empirical observation that we see, that if you have two numbers which have a common factor, then taking the common factor out and leaving whatever is left, whatever value is left. Once AC is divided by C, you're left with CA, and BC is divided by C, you're left with B. And the GCD of that one multiplied by C is going to be the GCD of the whole thing. And that's the reason when you start off, this particular process does the exact same thing. So this is AC and this is BC. What's common? What's C here? C is 20. So when I take out 20, what I'm left with is 36 and 54. Now to find the GCD of this, I'm further breaking it down. I'm taking 2 out and I'm left with 18 and 27. When I take the GCD of this, 9 out, and what I'm left with is this. And finally, you know that the GCD of 2 and 3 is 1, and that's the reason. Multiplying everything that's on the left gives you the answer. So if this question were to be written in this form, it's like saying, what is the GCD of 720 and 1080? And this would be nothing but 20 times the GCD of 36 and 54, which would be nothing but 2 times the GCD of 18 and 27. And that's nothing but 9 times the GCD of 2 and 3. And this is 1. The common factor between 2 and 3 is 1. And therefore, it's 20 times 2 times 9 times 1. In other words, 360 times 1. And that's the reason 360 is the GCD. So this is a methodology that can be used to pretty much calculate the GCD of any two numbers. All you have to do is look for factors. We can start off with the smallest prime factor, which is 2. Then look for 3. Look for any value. And the best part is, it need not be only prime factors. You could directly jump on to a larger factor like 20, which is nothing but 2 squared times 5. So I could have done it as 3 levels, but I'm just combining all of that together. And that's where pattern recognition really helps, because sometimes you could see the whole thing and say, hey, I know that it's not just 20. I could say this is actually a multiple of 180, right? So and things could have been really, really fast. 180 and you'd get immediately the value. Or you could directly jump in and say that 360 seems to be a factor, right? So being versatile with numbers will ensure that patterns and certain key elements of pattern recognition would kind of come to the fore in solving these problems. But even in the absence of that, you can methodically solve mathematical problems GCD is one such thing, and I hope you can use this particular concept to solve many problems in Olympiad. Wishing you all the best towards that. Thank you so much. If you like this video, please do like, share, and subscribe, and I'll see you in the next one.